All right, so here is an example of a trinomial. And so we're going to see if this is a perfect square trinomial. So the first thing I do is I look at the first term and I notice it is a perfect square, right? 4 is a perfect square and so is x squared. And if you look at the constant term, 49 is also a perfect square, okay? So if I'm looking at my A and B, right, I need to know what A is equal to and B is equal to, right? Well, if this is A squared, right, minus 2AB plus B squared, right? Well, if this is A squared, then that means A must equal 2x, right? Because if I take this and square it, I get 4x squared, right? So again, if I take this and square it, I get equal to what? If I use the distributive property for exponents, I get 2 squared times x squared, which gives me 4x squared. Okay? And so B is going to be 7, right? Because 7 squared is 49. So in this case here, what do I end up with? I end up with A is equal to 2x and B is equal to 7. So now, if this is a perfect square trinomial, then if I take the product of these two and double it, I should get 28x. Okay? And so of course, if I take 2 times 7 is 14. 14 squared is 28. I get 28x. So it is a perfect square trinomial. And so now I know that this is going to be what? A minus B quantity squared, because the first term is positive. Okay? And so in this case here, this factors into what? It's going to be 2x minus 7 quantity squared. Now you can check it by using the distributive property, right? So you could just take 2x minus 7 times 2x minus 7 and make sure that you get the same thing back, and you do. Okay? So you get 4x squared, you get the 49, and then if you take 2x minus 7, or 2x times a negative 7, and then you get another negative 7 times 2x, so that gives you negative 14x's. If you add them up, you get negative 28x. Okay, so that works.